Hello, everyone. Welcome to Advanced Visualization in R. Particularly, we are going to use a package called ggplot2, which is a very powerful package in data visualization. So in previous video, we've already seen how R can visualize those data in basic statistical plots. And those plots are usually quite commonly used across different software, across different platforms. So if you're doing some statistical analysis, you'll probably use those plots quite much. But in some other cases, we try to see more beautiful pictures. We try to recognize very interesting trend. So we can use ggplot2. So here I'm building some new maps here. For example, you can see a heat map looks like this, and 3D heat map looks like this. Geographic map, and a geographic heat map, and the geographic dynamic, because it's in PDF. You can show it. I can show it in a Word document or in the original GIF. Okay, and 3D geographic heat map here, right? You can see all those heat map. Okay, those heat map is quite useful. Okay, so I use ggplot2 to plot those fancy plots. It doesn't mean ggplot2 only plots those advanced graphs. All the previous one, all the bar plot, line chart, histogram, pie chart, ggplot2 can plot all of them. Okay, so besides all of those previous basic plots, ggplot2 can also conduct those advanced visualization. Okay, so heat map. Let's look at this heat map. Okay, the horizontal line is the hour of the day. So from 0 o'clock in the morning to 5 o'clock in the early morning, 12 o'clock in the noon, 3 o'clock in the afternoon, and 11 o'clock at night. It's all the day, right? And the vertical, instead of 3 sensors of line chart, right? Line chart in our previous basic plot, I use 10 different sensors. I believe should be 10, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, 20, sorry. So I use 20 different sensors. Okay. Suppose we are using line chart to plot, 20 lines here, right? We probably can see very clear about which line, belongs to which sensor, right? You probably can see some trend, probably here it goes up and goes down, but which way it goes, how up, we cannot trace it. It's quite difficult when lines goes more, goes up more than 10 lines, right? But for a heat map, you can clearly see this, this sensor, right? It's very low traffic volume, and this sensor, right? And for this sensor, it's almost like, somehow no data here, right? Somehow. So probably during some hour, those sensors maybe not valid, maybe off, right? And for all other sensor, they work properly, right? And we can see around the different time, different sensors show different pattern, right? They basically following the largest volume around 5, 6, 7 o'clock in the morning, and probably 3, 4, 5, 6, 5 or 6 o'clock in the afternoon. They probably the rush hour, right? The rush hour, the most traffic, the one following same pattern, but a slightly different. For example, in this one, 5126, the maximum and it's here, and the other 2126, right? Maximum is instead of 6, it's 5, 6, 7, 8, right? So 8 o'clock may be the most traffic volume one, and this one the same. So from heat map, you can see a trend for a different item for more than 10 items more easily, more conveniently, comparing to line chart, right? And here's the number of the volume starting, the lighter, the less, the lighter volume, the darker, the heavier volume, right? And among the 20 traffic sensor, this one is, contains the largest, the heaviest traffic volume. Okay, maybe we can find this sensor which road it was monitored, right? 5208, right? We'll get it back later, okay? We can find it. Okay, so that's 2D, two-dimension heat map, but it actually shows the three-dimension information, right? One dimension is the hour of day, the second dimension would be the ID, the third dimension would be the traffic volume, right? And we can also see a 3D heat map, okay, in this way. This looks like, quite fancy, right? We have, this is also hour of day HOD from 0 o'clock to 23, okay, because it's in a different order. When we show you in R, we can do a lot of tricks here. It is actually not a static map, a static graph. It is interactive, it is dynamic map. Okay, the Y still the traffic ID, the sensor ID, and the vertical Z means the heat map previously, okay? But in this 3D heat map, I didn't change the legend. We can also use the color to represent, for example, average speed, so that you can use one map to show the relationship across 4 different features, right? Instead of 3 for the two-dimensional heat map. Okay, here's the three-dimensional heat map. You can also see the traffics here, right? The morning traffic should be 7 o'clock, right? And 5 o'clock in the afternoon. And for this should be a different sensor, okay? Geographic map. So in previously, we put the sensor, right? Where are those sensors? Those little dots, okay? They are the sensors they put in Hong Kong. This is the Hong Kong map. But you see there's a little bit, misplacement here, right? It's because of the coordinates. For this Hong Kong map, that is Hong Kong map. I just not randomly, but kind of randomly, I tried to Google how can I find the Hong Kong map. I found one online, and they may use different coordinate system with latitude, longitude one for our traffic sensor. So that's why you can see a little bit misplacement here, but the general shape should be the same. Okay, so this highway may be a little bit misplacement, but it should be the highway from Kowloon to the island. I don't know how the island, Law something island, right? So this is Disneyland. This is the Hong Kong airport, right? So to the airport, there should be the highway should be somewhere here, right? But the sensor, a little bit, misplacement here. But we can see the geographical, the relative geographical relationship should be the same, okay, like this. So you can do that in SPSS, right? You can put a map and all the sensors here. So those are the location of the sensor. Those are the locations of the sensor. Okay. Once we have those geographic map and the sensor's location and the traffic volume, we can have a heat map on a geographic map, right? So it's no longer heat map like all the squares or the rectangles previously, right? You may still feel a little bit, kind of confusing. Or what does this mean? Or why do I need to care about this sensor, right? But if we group those sensors into district, Hong Kong got, as far as I know, it's only the 18 district. If we can find a map in more details into different parcels, and we can have a better heat map geographically. So I just mapping all the sensors into different districts, 18 districts, and group the traffic volume by the average. Think why I use average traffic volume? Why don't I? Why didn't I aggregate them, add them up all together within the district? Why? Think a few minutes, a few seconds. Because if we put a lot of sensor in that area, we add them up, the traffic volume will, build up. But the actual traffic volume might not be that much, right? For example, in a highway, same highway, the same set of vehicles passing by, right? If we use 3 sensors, for example, in the airport, 3 sensors here, right? If we use 5 sensors here, the same car counted 3 times here, 5 times here, right? So if we use the total volume, the summation, adding all the traffic volume up, it won't reflect the true traffic volume. Instead, if we use the total volume divided by the number of sensors, which will give us the average volume, it's better than the total volume. So that's why I use average volume here, right? So here the average volume of Hong Kong at 3 o'clock in the afternoon in the day of March 8th, 2023, because that's the data we have, okay? So this is geographical heat map. Okay. And this is a dynamic one. It can be shown in a PDF file. I can show you in a real GIF file. Okay, give me 1 second. Okay. I hope everyone can see it clearly, right? Let me see. Let me expand it a little bit. Where is it? Where is it? Where is it? No. Give me a second. What? Yeah. Okay. So this is a dynamic 2D heat map. You can see here's a clock, right? So 1 o'clock means from 0 in the morning to 1 o'clock. So it will be 23 and 24, right? 24, that means 20, that will be 11 o'clock, 59 minutes. So it's starting from the early morning all the way till the midnight. You can see the pattern here, right? You know, in the morning, 10 o'clock, 12 o'clock, it goes up, build up at 7. Then after that, it goes lighter. You can see this pattern. This is just for 1 day. Now, suppose we have a whole month data. We can probably expect the periodical trend for the traffic. And in the early morning, the traffic is very low among all the 18 districts in Hong Kong. But gradually, you can see the traffic builds up here around this area. This should be Golong, and this is Hong Kong Island. And in Hong Kong Island, we can see most traffic is going to those two areas, right? I guess this is the central area in Island, right? And we can see our lovely CTUs here, right? Somewhere here. And this should be Da Wai, right? It's a train station, I believe, right? So more traffic's here. And here should be, I don't know, Train 1, maybe, Train 1, right? I don't know how to pronounce in Chinese, but something like that, okay? So we can see those two areas, those three areas, they build up lots of traffic during morning rush hour and noon, and in the afternoon for the afternoon rush hour, right? But it's still not so clear. It's still 2D, and we just get the general concept. Just every traffic from those suburban coming to those central area here, right? Okay. If we build a 3D map, it will show you much clearer the picture, the sense. For example, here we can see this one, Dawei is somewhere here, right? You can see the number here. And we can also build a 3D dynamic map. So it will be 3D dynamic map. Okay, here's the 3D dynamic map. Okay, you can see somehow, sometime, this area just coming, disappear, right? What does that mean? The sensor in that hour may not be valid. So the whole volume somehow disappear. And we can see the volume growth starting, still starting from 0 o'clock, right? Here's a change, right? But they do not, all the way, the whole island goes up, right? You can see it goes out starting from some places, right? Okay, you can see 0, 5, let's starting from these places, right? I don't know which area, and goes to Chengwan, then goes to somewhere here. But Changwon really the most congesting area should be here, right? And if we have a monthly data, we can see the monthly trend, not only that day, right? We can see the 3D heat map give us much better visualization about the traffic, right? And again, if we have the geographic map in a smaller parcel, a smaller area, we can mapping our traffic data into a smaller area, and it will show us which place will have the most traffic volume. And if we use instead of we use the height to represent volume, we use different color to represent occupancy or speed, which may give us a much more insight, many insights here, right? So for example, if the volume is high, the speed is low, that will be a congestion. If the volume is high, speed is high, that will be a busy hour. So that thing won't, it's common, right? It's just rush hour. It won't give us any bad, negative impact on the road, right? The only problem, the most severe issue would be the high volume, low speed. That will be the traffic congestion, and the city government should, put a lot of focus on, right? Okay, so that's it. So how can we build those fancy map? Again, let's go back to our code. This time we go to advanced VisR. Okay. So again, let's go back, load data here. ggplot2 heat map. Okay. So we use ggplot as a function to plot every map. For heat map, actually we'll use those geom tile. Tile, is like a brick tile, right? They tile them up, right? So this is the function. And they have AEC representing aesthetic. So aesthetic is like, the beauty, right? The appearance. In aesthetic, we have X, so the number of X, Y, the value of Y. Fill, that's the color. How we use what number to fill? We use this total volume to fill the color. And what color is light blue or something, right? Volume is like high or low, but so we go low value, we use the scale fill gradient. Low value will fill with white, and the high value will fill those total volume with deep sky blue 3, right? There's some kind of a code book in R. So if we go to our colors, okay, you can find all those codes. So we have either use this name, those are term names. You can directly type those English name, or you can, type this kind of code, H-B, H3 something to represent this color. Okay, it's quite neat. It's kind of a cheat sheet. So just pick one of I like, I probably like this deep blue. This looks more, my personal taste. Okay, so I'll put the high here. Okay. Again, instead of XLab, YLab, main, in ggplot2, they use labs, okay, labs function. Inside labs function, they got 3 arguments or 3 parameters. Title is the main title. X is the label of the X, Y is label of Y. Here, guides is the setting of the legend. So let's again to plot this data. You can see here, right? So data is a heat map data. I just pick size equals 20. I random pick 20 sensor. Okay, and X is hour of day. Y is detector ID. X hour day sensor ID. Fill is total volume. So high volume. High volume goes up to deep sky blue 3. The low volume goes to white. And everything between will be set into 4 different categories. Okay. So 0 to 1,000, 1,000, 2,000, 2,000, 3,000, 4,000, or like this, okay? And in ggplot2, it's different from basic R. You need to set everything together and use a new line. They use this plus to add more parameters into the plot. So they plot something basic, they add more things here, add more things here, add more things here. Okay, so you can keep adding as many parameters as you want to customize your plot. Okay, So here we can see the plot. Use zoom here to see it bigger. Okay, so this is the heat map. Okay, but how do we plot those 3D heat map? We need a new library called Plotly. So if we don't have it, you need to install the package. To install the package Plotly, again, we use Plotly to build this data. Okay, instead of plots here, we use a viewer here, and this is an interactive. Let's zoom in. Okay, this is viewer. In previous one, I told you it's kind of difficult to see clearly, right? But you can see, you can left click and drag it, okay, to anything, any angle you like. Okay, and you can also zoom in, zoom out. Okay, zoom out, zoom in. You can play with it, all right? If possible, I didn't change the color, but you can change the color. Instead of volume, you can change the color by speed. So in this case, Z, so the vertical value Z here is already traffic volume, but we also use the color to represent the volume. So you see, going more light towards the red means heat, right? Why it's called heat map, right? Too hot from the physics, from the thermal temperature, right? So we can change the volume here. Instead of volume, we can use speed here. So the volume will be shown by vertical line, but the speed will shown in a different color. So if we have low speed, high volume, it will be a congestion. High speed, high volume should be okay, right? Low volume, high speed, totally okay, probably some highway, right? And this is the 3D map and interactive. Okay, you can play yourself. Geographic map, we need to use a new package called SF, and we need to load Hong Kong map from this SHP file. So on Canvas, I upload a 6 map file. Even though we only need to load this one SHP shapefile, we need to download all 6 files because somehow those 6 files connected with each other. So something in this shapefile, they try to call other data in different files. So we need to download all 6 files. Okay, we need to load the map. And this volume OCC info is a traffic location info. Okay, and we can go to see this traffic location, right? It's like traffic number, which road, right? We have English, Chinese name. Yeah, previously we tried to find something, remember, something may be broken in the heat map, this one, AID 03104. Okay, now we can check it. Okay, sensor AID number equals AID, which one? 03104. 03104. Which one? It's this sensor. Okay. I still don't know where is it, right? But we can do it later, okay? So once we have sensor data, map data, we can plot sensor into map, right? Which will be here. Then now we can check it. Okay, where is our run sensor? Oh, here, somewhere in Hong Kong Island. So let's go see. So somewhere in this Hong Kong Island, this sensor is broken, right? Because we see in the previously, dynamic map, there are so many traffics there, but it's almost like 0 all the time, right? You see, almost 0 all the time. And in our dynamic field, in our 3D fancy field, right? they have some volume here, but not zero, right? But this one always gives you a zero. Some problem with this sensor may not be valid. Okay, and let's see whether it's valid or not. Valid or not. Oh, we can see it here. Okay, it didn't show. It will show you in a traffic volume data, not sensors location data. Okay, so that's how we find the sensor location. Let's delete that one. Okay, to get our map here back. So geographic heat map, we need to combine our location data. Okay, this is location data with our traffic data. Okay, to create a data called traffic new. Now we can see the geographic heat map because we combine our traffic volume with our geographic data. Okay. So again, we use ggplot. We use geosf. Remember, we load a new package sf here, right? So this sf loading those map data. So ggplot2, plotting all those fancy chart, the advanced chart, the heat map, the combined chart, with different color, the tile chart, and combine those advanced chart with other options. Here, SF representing the shapefile, reading the shapefile to plot a Hong Kong map. But we may have other functions. A very famous one is called Google Plot, right? In R, they do have a Google Plot function to access Google Plot. However, years ago, it was open access. You do not need to, call anything. Just download the package, use it, fine. Recently, Google issued a new policy. You have to register a Google account, and in your Google account, you need to create some called something like API key, and use that API key in your R code, then you can have the access. So you need to use R to log in your Google account and using those API key to access Google, which is quite troublesome right now. So I just simply use this shapefile to access the Hong Kong map instead of using Google Map. We can use that. If we use that Google Map, we plot those sensor location, it will give us a better matching instead of this, mismatchment, misplacement. But for illustration purpose, just use this shapefile. It should be fine. Okay. So we combine the map data with our traffic volume data to build this heat map. So in this heat map, instead of use geotile previously, we use this geosf, and we fill the average volume as the color, and we also set the color low and high. Limits means the limits of the color, okay, the fill. So starting from 0 to 3,000, the total traffic. Okay, so this is how we build a 2D geo map. Then, how can we build a dynamic one? There are multiple ways to create dynamic map. In this video, I only use something called Image Magic, a different software. So the logic behind is we get the data, and for each hour, right? So then we have a for loop. Remember the control flow last week I taught you, right? So for each hour, we create a file, okay? And we use this image magic, this software, to combine all those images, those 2D PDFs, all together into one GIF, into one graph. Okay. And I did it similarly for the 3D one. So this is the simplest way to create a dynamic map using GRF format because it's just frames. Okay, we can also create an MP4 file or MOV file through different software. Now, if you're interested, you can Google it online. You will find lots of different software to do this, but they all share the common logic here. Okay. And for 3D graph, we need to import a new package called the ray shader. Okay. For ray shader, you need to install, instead of, you need to install dev tool first. Okay, install package, dev tools. Then from this dev tool, you need to install from GitHub. Then I believe something ray shade. I got the author. Let me try to find the author. Ray shader. No, sorry. Oh, because it's not that one. So let's Google it. Okay. Let's just Google it. GitHub. Yes, this handsome guy, Tyler. From this handsome guy, Tyler. This guy is awesome. They made our life much more simpler. Okay. So typically we try to use install package to install some packages from Korean, which is the official R community published by our archive. But this guy, he didn't publish his package on the R community. Instead, he publishes one on a on a website called GitHub. So he has his own GitHub page, and this ray shader is one of his project. I guess he's working on it almost every day, right? Not every day, but very frequent. Last month, he just updated his package, so we can see a lot of people will send, contribute to them, will send comments to him, and if he tests it okay, he will accept the code and publish in this website. And for us, we need to download it through this. Okay, I just commented out. Okay, just need this. Okay, after we install this ray shader, let's just library ray shader. Okay, so a ray shader can convert a ggplot2 2D two-dimension file into a 3D. So we need to plot our 2D file first, then use this function plotgg to convert our 2D file into 3D. You can see this stop sign still here, so it's still running for a little bit. I believe a few seconds, the plot will be shown here. Let's just wait a few here. Okay, it pops up. Okay, this is the ray shader is ready, and you can see I can drag it and turn it to different angle. It's still the 3 o'clock in the afternoon in March 8th, and you can see the height, right? You can see the height quite, the difference here, right? But for the dynamic one, you cannot, rotate, see everything, because I create a static picture for each time, for each hour, and combine them into GIF. But if you use the Plotly, like the previous package, Plotly, you can also use Plotly to plot this dynamic map. But I just didn't have the time to do that. So you see this Plotly. You can also use this package to create a dynamic map. And it will be a slide format, so you can drag back and forth to see the trend. And that's more neat than a GIF one. But this one is mostly convenient one. So similarly, for each hour, I created a a 3D file like this. No, sorry, like this. Okay, for each hour, then combine them together. Use the magic tool, image magic, and I use render snapshot to create this. So that's in my 3D folder. Okay, you can see lots of PNG file. Then I create this, right? You can see it. I cannot, drag and rotate, zoom in this file, but it works. I'll show you a good visualization. So you can see R can do lots of advanced visualization comparing to SPSS, SAS, Stata, all those, old type, stereotype statistical software, right? Python can do it too, but Python is much more difficult to learn comparing to R. So you may feel the pressure to learn R right now because you only have 3 hours to learn it, but Python is totally a different level. I won't introduce Python in this class, but if you are interested, you can play with R yourself. So that'll be it for this week's class.